Hi, thanks for taking the time to join me today. For a brief introduction, my name is Ben Polzine. I'm a former petroleum engineer turned data scientist. As an engineer, it was all data-driven, very analytics-based, and fell in love with the power of data and really wanted to dive all in on the machine learning revolution. And here I am now. After finishing up my data science diploma from BrainStation, I wanted to pursue deep learning even further. I found the deep learning specialization on Coursera to be extremely valuable. It was provided by Andrew Ng of deeplearning.ai. Really dove into all the inner workings of deep learning models, building them up from scratch with NumPy and applying them to various problems. And from there, I've been inspired to pursue the TensorFlow professional certification. TensorFlow is a deep learning tool built by Google. Very powerful, very useful tool, and I've been working specifically on some computer vision problems that I'd like to share with you today. Started with the very basic, the hello world of computer vision, the MNIST handwritten digits dataset, very classic dataset. It's included in the TensorFlow library, so you can load it easily, automatically. It's 60,000 images in the train set, 10,000 in the test set, with handwritten images. As an example, here's one, just the first one on the data set appears to be number 5. Yeah, and so there's thousands of these for every digit, 0 through 9, and they're very small. They're 28 by 28 pixels. With computer vision, the smaller the images, really, the more efficient your model is going to be. It can limit maybe some of the feature extraction you're able to do with more complex images, but it does really improve your efficiency of the model. And so for this one, just built a very basic deep learning model. Deep learning is a little bit more advanced than just standard machine learning in the sense that it utilizes these hidden layers, and it's built off of our understanding of the neural network in our brain. And so what this does is it takes the input layer, which is in this case an image, but it could be applied to a variety of problems such as predicting housing prices or really any variety of machine learning applications. And within the hidden layers, it can find a variety of different features and colors or pieces of the image, and use those to identify the class associated with that image. In this simple example, going from a dog to a bird to a cat. In ours, it's a multi-class example, either 0, 1, 2, 3, and so on to 9. And so it's just, again, a fairly simple deep learning model. In one useful tool when training these types of models in a learning scenario is to do what's called a callback function. And what this does is it'll train the model to a desired accuracy and then end once it reaches that accuracy, so you don't waste time training endlessly. And so, yeah, we built a simple deep learning model, trained it, and although we didn't reach our 99.99% very aggressive accuracy after 100 epochs, we were able to reach a validation accuracy of 98%, which is pretty impressive for a very simple deep learning model. So a great introduction, great start to computer vision, and really excited to keep going further. I have a more advanced project that I'll go over in the next video, but just wanted to share this and get going.